So one of the key things is measuring equipment. So when they're asking about some methods, and this is actually from IGCSE as well, name the measuring equipment.
Was you gonna ask that?
Equipment always. Well, there was marks for it.
Ah, okay.
So the second one is energetics. So calorimetry. And what would be the main source of error? So one of the questions that they're asking is methods, name the measuring equipment, and the other one is safety precautions. But the safety precautions can't just be wear safety specs. They have to be specific to the chemicals that you're using. You cannot, though, lose marks for suggesting that you should be wearing a lab coat. So,
how would these be, like,
so
to each chemical?
the way, so there would be two, for this methods question, they would say, what are the things that you could do? And then you just have to basically scattergun approach, name all the measuring equipment, name the processes that you're actually doing, and then think about the equipment, what's going on, and think about the specific safety conditions to that experiment. So if it was, for instance, involving ethanol, you're using fuel burners or whatever, fire precautions need to be taken into account, so flame-proof fire blame. Or if you're heating ethanol or something like that, I think they may do, if they do colorimetry, then one safety precaution could be well-ventilated room. Why do you need a well-ventilated, not just for safety, but why would you need, so for instance, do it in the fuel cupboard. And the reason for that is to prevent carbon monoxide poisoning. So, and if it was calorimetry, so the things that you would need to be aware of for this, what's the number one source of error for calorimetry? And this feeds into your method.
Heat loss.
Heat loss. So, or heat transfer, because it could be an endotherm. To plugging on. And how can we fix this?
Insulator.
Insulating. What kind of insulator? Copper.
Polystyrene.
Okay, excellent. So it needs to be a named insulator. So for instance, polystyrene. And another source of error would be incomplete combustion. So must excess. So one of the things that they may be doing is, and they could do that for the nature of science things, what they could do, and maybe hopefully they've thought about this, is they just get a bunch of submitted IAs, and they read through the level 7 IAs, and then they just pick one of those for the question and for the mark.
That's going to be the Ising clock experiment.
Actually, the way that I would do it is I would look at statistically how many are entered. If I wanted to maximize the marks, statistically how many are entered for particular topics, and then so choose For the first question, choose the first one. The second one, and the third one, the third one. Then there's no, that suggests then that the largest number of students will have the most exposure to that question. So you inflate, well, you're not inflating grades, but you're catering to the market.
So how would you step out the calorimetry experiment?
You
I know
would-
how it works, but like really specific. Just so
Okay, so what we would need is a diagram. And,
So even if the question's just in like line paper, you would have to
include a diagram.
include a diagram? Can you do that?
Because if this was like, I suspect most of the questions seem to be 1 or 2 marks, so you wouldn't have the space or the necessity to do this. But if you got like 4 or 5 marks, then a diagram would be really important. So you would have, so for instance, the burner, and there you have the fuel. And the other reason why you should do the diagram isn't just for the examiner. You're laying out your answers for yourself as well. So if you see the diagram, you can say, well, how is that can going to be kept there? So well, it needs a clamp stand. And what this nature of science is about the practicalities, a teeny tiny bit of the practicalities. So this would be water, but how much water should we have?
The known amount?
Yeah, exactly. What would be a useful known amount?
500 ml.
Okay,
6
500 or 100. 100 would be, and it wouldn't be ml.
Yeah, so I think it's good.
And what could we make this, bearing in mind heat loss is important, what could we make this speaker out of?
Polystyrene?
It would burn.
No, I mean like insulated around. Well, because it's out of
It would
metal.
we would want to make it out of metal, and we would make this out of copper. And what you would need to do, or what you could do, is when you're talking about your write-up, say, well, actually, some of the heat is going to go into the copper as well, and your calculation needs to take into account the specific heat capacity of the copper and the heat that is also in the copper. And then we're going to be measuring this with a thermometer. Will a digital thermometer be more accurate?
Yes.
No.
No.
It may also not be more precise. So both thermometers, but you would want a thermometer that reads to say 0.1 degrees Celsius. One of the marks of this method is for precision. And you could check the thermometer, calibrate the thermometer. With and this idea of a calibrate, I would say is a question I would quite like to see, because how do you know your standards are standard? How would we know that a thermometer really was accurate? What could we use to calibrate it?
Known amounts, like a known value.
Yep. So a known temperature.
Yeah, known temperature.
So what was a very
Boiling water.
excellent boiling water? 100 degrees Celsius. And okay, so heat loss is a issue, so we want to insulate it, but we are caught with the problem that we also want to have good ventilation. So one of the problems that would, if the examiner was reading a lot of IAs, on this, one of the problems is if you do this in a fume cupboard, the flame will flicker. So they need to, so for instance, you have a wall here to allow air access, but prevent the flickering of the flame. And that helps promote more of the heat coming into there. And then another important thing is and how can we make this more reliable?
Repeat it?
Exactly. Repeat 3 times. And what can we do with the data? In terms of data analysis, what can we do? We've got 3 points. Which one do we choose?
The mean?
Exactly. And it's a lot of this stuff, and actually all of these marks are basically, when you see them on the mark scheme, dead obvious, but they need to be mentioned. They need to be very clearly signposted. So repeat 3 times, take mean. What else could we do if this was an IA? So, and our data analysis would involve taking the mean, possibly mass of burner, before and after, using scales. And this was the reason why I'm saying this. This was on the most recent one. Using scales to 0.001 grams. And then, so really it's kind of a little bit like but it is basically an extended, an internal assessment. And then for the conclusion, what would we be comparing this with?
Comparing. Non-values?
Exactly. Values. And they would be very explicit about calculating error. So they would say, but what things could produce error in this random error?
That could produce random error.
Yeah.
I don't know. The distance from the fuel to the.
That would be a systematic error. So random error is from measurements.
So from the mark.
So wherever we're taking a measurement, that's a source of random error. The definition of random error, actually, because I was looking at the textbook, normally I think textbooks are terrible. Then when I looked at the textbook, I thought it was great. Then I looked a little bit more carefully, and it's all right. They include some bits from the old syllabus, and they're not quite sure about what the syllabus is either.
That's good.
So their idea on random error, in the textbook they talk about random error as being, as the IUPAC definition, which I don't think IB is going to use because it's too hard. But if you were to do the It's the error you would get if you performed the repeatable experiment an infinite number of times. So it would always be around about there, and that's caused by the instruments. So here our thermometer is one reading, hundreds, and wherever we've got any values, and this is why you have to put the values in. So the reading of the volume of the water and the mass of the fuel. If you're measuring, and you should be doing that as well, measuring the distance between the flame and the vessel, that's another source of, now you've got a ruler there, another source of error. You wouldn't be expected to combine them all together though. They would say, what's the error on the value of the water, or the measurement, or the fuel? How would we get 100 centimeters cubed of water, measure that accurately? What would we use?
How?
Yeah.
Okay. Measuring cylinder.
Yeah, measuring cylinder. What about 50?
50 centimeters cubed.
Yeah.
Two measuring cylinder.
You could use a measuring cylinder, or you could use a burette.
Maybe right, yeah.
Or you could also use a a volumetric pipette. So once you get to 25 or below volumetric pipettes, so we could reduce random error by having, instead of a thermometer that reads to 0.1 degrees, having one that reads to 0.01, and 100 centimeters cubed, having a more precise measuring cylinder, or using, no, that's all I'm going to say, but there are other ways as well. And then with this, a more precise balance, so add an extra 0 to that. And that would then make our reduce random error. Systematic error would be stuff like heat loss. And incomplete combustion. How would we know incomplete combustion had happened?
People start to die in the room.
Yes. What you have is you get the students with asthma, and once those dies first, then you they are the canaries. No, so what would we be able? So carbon monoxide is invisible, so
Yeah.
we can't see carbon dioxide. But one thing we can see when we get incomplete combustion. Chimneys have a lot of it. In the olden days, you used to get not smoke. Chimney sweeps used to get rid of this stuff.
Okay. So it's like, I don't know.
Send them up with brush, and they brush it all out of the chimney. See it on a beaker if you put it next to a black flame. Oh no, a yellow flame. Yellow flame produces this. Carbon, pure carbon.
I just pure carbon.
Soot. So you would see soot from incomplete combustion. So they, I don't think, would ask outright, how could you detect incomplete combustion? but they might say a black residue is forming on the bottom of the beaker. And that then tells you that you've got incomplete combustion, which then means that you're assuming more fuel is being burnt than it actually is. So the direction of that error would be that the fuel contains more or less energy than you're calculating.
Sorry?
If we got soot here,
So,
what would be the direction of the error?
You're calculating more heat than it actually produces.
Less. So that soot is fuel that hasn't burned,
It hasn't burned yet,
but we're assuming that it has.
but it has.
So,
Aren't you?
we're saying, so say for instance, 2 kilos of fuel has burned, but actually a kilo is soot. So per kilogram, this fuel is calculated as less energy.
So exactly, but I just said the opposite way.
Yes, you had too much energy. No, did you say the fuel
I said
had?
that you're calculating that it's more energy than you think it is, isn't it?
No, it's less energy. Your calculation would produce a lower.
Oh yes, yeah, it's less energy. Yeah. Okay.
Per kilogram. So, so excellent, but yeah, no, it's very easy. I could very easily have been arguing the opposite to the correct one. So what's it called? So so the soot would reduce the calories of the fuel, and the way you could detect it is by looking at it. You could measure it by measuring the mass of the beaker, but most of the soot actually is lost to the air and to your lungs. So, and also, soot is only one product. Carbon monoxide is a gas. But basically, that would be maybe 10 marks.
Wow.
So this would
So
be
what topics? 2 questions. What
Yeah.
topics do you think are going to show up?
this one.
I mean, but other than this one,
Other than this one,
do you think it's because do you think they're going to part from different topics, or are they going to stick to the topics that they showed in the last exam?
last exam was titration. So-
no, but I mean not only that, but I mean like the other ones. The other ones.
In terms
think I
of
have
if
the exam.
in terms because I used to teach this thing called the A level, and in A level I actually went through. This is where I started to learn the patterns. I went through all their practical, the A level practicals that they did. So in an exam condition, they actually had to do a practical. And one of them, the practical involved breaking big jars all the time. It was hilarious. So, and I looked at, and these are the most common examinable practicals. First one's titration. Number 2
And probably
is
they're going to have
energetics.
something to do with that as well, like in the nature of science, but also to do with stoichiometry, for example.
What they want.
Or enthalpy, they could relate that.
This
to
is enthalpy, yeah.
Yeah.
So this is enthalpy. What they want is, because these are the only 2 really quantitative things that they can assess you on. So, and actually it turns out they want to ask the same question for standard level and higher level, so that then limits it even further, which is actually quite useful for Alex. It means then, because he could, one thing that they could do is a redox titration. But they've already done a titration, so I don't think they would. Or they could also do a electrochemical cell, but that's not really on your syllabus very much.
Yeah. What did it? No, there was just one question
Yeah.
in the multiple choice one. I don't
Yeah.
remember it. On that.
So it's, I think, so they there's 2, because what they want is a number which is quantitative. So, and they also want the experiment to have a clean source of error. You could get something like burning magnesium and calculating the concentrate or the stoichiometry of magnesium oxide.
The second thing is, I don't know if you could do that, but perhaps list the possible equation, the possible reactions that they could ask you. I know there's like a lot, but I mean
For-
going from like the real basics to the more complicated ones, like
The-
combustion, then,
so-
neutralization, but then also producing salts, you know, those things.
Salts isn't actually that big, it's bigger than
Because
IGCSE.
sometimes, I think it happened in this exam,
Yeah.
the last one, there's a question and then they ask you to balance out or to show the elements in the reaction.
Yeah.
And then later on they ask you like stoichiometry questions on that
Yeah.
equation. And so if you missed out the equation, you're probably gonna carry forward all the error marks for like stoichiometry. So
Yeah.
sometimes it's really important for the questions for you to be able to like know what element's gonna react to the other. That's what
Okay, so the main one would be, and this is quite important, and actually in IGCSE they asked a question which I nearly couldn't solve.
Wow.
And the way I solved it was really hard. I actually had to introduce an extra step which wasn't in there, and they weren't. So I did it using IB equation solving, which I wouldn't even think is IB doable. But I solved it. But yes, how the students were expected to know that, no idea. So I think though that mark was just meant to be possible. So, but it was based on this idea. And sometimes you could get an acid and a base which aren't. So this is for Bronsted-Lowry. Sometimes though you can also get acid. So this is aqueous, AQ. But you can get acids and bases which aren't aqueous. So this relates to pH. So non-metal oxides are acidic. Make salts. Perhaps the easiest or more straightforward of this would be CO2 plus CaO goes to make CaCO3. Going this way is thermal decomposition. I think top tips then in terms of what's going on and trying to work out. So is it an acid or a base? If it's an acid or a base, you should be making a salt. The main thing though is how many spaces do they give you for substances? So there's one question that I saw, that was
usually they don't. It's just like the box, the normal box. Then they ask you-
don't they give you,
Then they ask you like, I can't find the question,
Yeah.
but like, they show you an experiment with certain types of chemicals, and
Yeah.
then they ask you the equation to write the equation down. So I don't know if they would ask just like in the IGCSE where you had like, if I can't remember.
do you remember, do you remember
so like
how to
acid-
do redox equations?
Yeah, the
Okay.
balancing out.
Yeah. So you balance first for elements other
But
than.
the issue is sometimes I don't know which elements like combine with each other. That's the thing. That's what I mean.
Oh, okay. So some key thing is sometimes water is a big one, and carbon dioxide can pop out. In terms of what could combine with what, this idea of making a salt forces everything together. Ions that you could make are carbonates, phosphates, BO4, 3 minus. These are nitrates, NO3 minus. But these would all be salts. So salts are basically all ionic substances. And then SO4, 2 minus. Those are all, oh, and then chlorides. 2 minus, bromide. So, in terms of what could combine, otherwise, and these are the only ones I think that could produce something slightly unseen before. Otherwise, they have to tell you if it's a compound, if it's a molecule.
So would they
Because
ask
there's
you
no
just
way
like
of
the
knowing
ICC where you
molecules.
have equation with the metal plus acid, for example?
Yeah, always makes a salt.
So it's a salt concentration.
Exactly, yeah. So basically, if you understand that metals and non-metals always produce salts, you would be all right. For molecules, they don't do the chlorides anymore, but yeah. So all of the molecules, basically, you know from alkanes, ETC, alcohols. So these would change. So in your exam, they actually had alkene, alkanol. Alkanes become alkanyl, and then alcohols, alkane. So it's just alks, ALK, and here for alkenes, alkenyl, alkenyl. I've never seen that question before, which is why it threw me. I've never seen that in.
Yeah, but it was just one multiple choice question.
It was one, I know, but so it was. It's an odd direction. Because normally they ask, so what they're asking for is the homologous series, the name of the family, not the name of the functional group. This is the family, the functional group is alkene. It's a pointless distinction. That's why I think it's silly that they do. So I thought that's not very great. But, because actually, yeah, really the core idea of it is the group, not how we're going to be calling it. Anyways, right, so that's kind of most things, given time constraints, because I'm now teaching my little cherubs. Magnificent.